We're going to continue and complete our discussion of Chapter 6 with the topic of periodic trends. Before we get into the actual trends, we need to have a little bit of vocabulary in place. And one of the things that we need to talk about is something called effective nuclear charge. Effective nuclear charge is the positive charge that is experienced on the electrons by the nucleus. So if I were to have this atom, and I added one more proton inside here, it would pull this electron tighter because I'd have more positive charges in here than I had before. And so essentially it's the pull the nucleus has on the electrons. And as you add more and more protons in, it's going to pull those electrons closer. Electron shielding is another example of vocabulary that we need to look at. And this just happens when you end up with atoms where you've got multiple energy levels. The energy levels on the inside will essentially kind of absorb, in a way, the pull of the protons from the nucleus. And so the electrons in the outer shell don't have as much of a pull from that nucleus. The other thing that causes that to happen, in addition to the shielding, is the distance. So as you increase the distance away from the nucleus, the pull of the nucleus is going to become a little bit weaker just because the distance has increased. And if you think about that in terms of magnets, if you've ever played around with magnets, if you hold two magnets at arm's length distance away from one another, you don't feel the magnetic pull between those two magnets. But as you bring them closer and closer and closer together, you start to feel that pull to the point where at the end, when they get really close together, they just snap into place, and you can hardly even hold them apart at that point without putting a lot of extra energy into it. So as your distance increases away from charged particles, the force is going to decrease. Ionization energy is our first trend that we're going to talk about. And what ionization energy is the energy that's required to remove an electron from an atom. So some atoms give up their electrons very easily, and those would be the metals. So the atoms that are located on the left side of the periodic table will tend to lose their electrons very easily, whereas the nonmetals don't. In fact, the nonmetals attract the electrons that the metals give up, and that's how they're going to form compounds. So if we had a neutral lithium atom, for example, we add in some energy, some ionization energy, in fact. When we add that ionization energy, we can pull that electron off. That's going to make lithium a positive ion then, because you're going to have 3 positive charges, but now you're only going to have 2 electrons, your negative charges. So it's going to have a +1 charge associated with it. As we look at our trends then for ionization energy, when we look at that, as we go down the periodic table, it's going to decrease, and we go across, it's going to increase. So each element has more energy levels than the one above it. So when we look down our periodic trend here, our group, as we go down, we're adding more distance away from the nucleus. So it's going to be easier and easier to pull that electron away. I kind of liken this to like a mom with a newborn baby. Really close, keeping that baby really tight. Not easy for it to get away at all. Here, maybe it's a toddler, and now, mom holds it by the hand, never lets it go, never out of her sight. So a little bit easier than here when she was holding that baby super tight, but it's still not getting away very easily. Move down here, now they're in kindergarten, walking to school by themselves maybe, easier to get away. Here they're starting to go to junior high, go out to dances with people and, have fun and go over for sleepovers and stuff, so mom doesn't have as much control. High school, getting your driver's license, here, they're going off to college, and here they've got their first job on the other side of the country. So by the time you go from the newborn all the way down here, your distance is increasing, just like the distance between you and your mom is starting to increase as you get older. not holding on quite as tight. So as you move down, ionization energy is going to increase or decrease because it'll be easier to pull those electrons away as that distance is increasing. As we move across a period, we're going to increase our ionization energy, and that has to do with that effective nuclear charge. So if we just look at this period 2 group of elements here, period 2, here's your lithium and your beryllium, and we've got 3 protons here. Here we've got 4. Again, we're in the same energy level, that energy, the second energy level. And as we move across here, we're gaining more protons. And so the protons are increasing. Our distance from the nucleus, for the most part, isn't changing a huge degree because we haven't added another layer in there. So as we move across, we're adding more positives in, we're adding more pull in for those electrons. So it's going to increase as we go across. Atomic radius, then, is the distance from the center of the nucleus to the outer electron. As we move down, you're going to increase that radius, and that's because you're adding more energy levels as you move down the periodic table. Each one you're adding more layers in, and so because of that, you're going to end up with a bigger atom. As we move across the period, though, it's going to decrease. And that has to, again, do with that nuclear charge. We've got 3 protons here pulling on the outer electrons. Here we've got 4. So they're going to be pulling it in tighter. And you can see that the radius is decreasing as we move across. And that's because we're adding in more of those positive charges going across. But we're not increasing our distance dramatically because we haven't added another energy level in. Our next trend is electronegativity. Electronegativity was a scale that Linus Pauling made up, and it is numerical values. They give values to each atom, and fluorine happens to be our base. And fluorine is the element on the periodic table that wants electrons the most. So electronegativity means that it's the ability of an atom in a compound to attract electrons, and fluorine wants those electrons more than any other element on the periodic table. So they assign that with a base number. It's actually 4 is what they give it. You don't need to memorize that. And the atom with the higher electronegativity will pull the electrons more strongly than the other atoms will. And electronegativity becomes important for us as well when we start naming compounds and writing their formulas, because the least electronegative element is always listed first in a compound. So if you had H2O, for example, your hydrogen is less electronegative than your oxygen because it's written with the least electronegative element written first. So we'll get into that more when we get to chapter 7 and 8. So if we look at the trend in terms of our periodic table, if we go down a group, we're going to see that the electron shielding is going to cause our electronegativity to decrease. So you have francium down here that has the least electronegativity of the metals. And it's going to be very easy to pull off that electron. And because of this low electronegativity, they give away their electrons. And if we go across the period, we're going to increase. Now, the noble gases, for the most part, they don't have an associated electronegativity. And the reason for that is they don't need any other electrons. They're good. They have filled outer energy levels. And really, that's the goal of atoms, is to fill the outer energy level. And they're going to do that in one of 3 ways that we're going to talk about more when we get to the next chapter. But one of the ways is they're going to, as these metals do, they're going to give away one of their electrons. They can take an electron, as a lot of the nonmetals do, from the metal. They'll take the electron. And then the third way is to share electrons, and that's done amongst nonmetals, like the water I was talking about just a minute ago. So as we increase, electrons are going to be attracted more strongly, and that's going to give you an increase in the electronegativity. So we need to talk just very briefly about what a cation is. Cations are positive. And what that means is a cation is formed when an atom loses an electron. So if we think about like lithium, for example, that we were talking about a minute ago, lithium has 3 protons. In an atom, lithium would also have 3 electrons. But now lithium is losing one of those electrons. So now it has 3 positive charges, but only 2 negative charges. So it's going to have a positive 1 charge associated with it. We call that a cation. So if you think about the T in the center of the word cation, think of that as a positive symbol. And then remember that cations are positive. They have paws like cats do. So that's an easy way to remember that. We can also form anions like the fluorine. Fluorine is going to gain an electron, so it's going to have 9 positives. It's going to gain an extra electron, giving it 10 negatives. So that is going to have a -1 charge associated with it. The reason why I bring those up is because the next trend that we talk about is ionic radius. So these things, these cations and anions collectively are known as an ion. And we can look at the ionic radius and see that there's also a trend there. So as we go down, we're going to increase our ionic radius, and that has to do with adding more layers in. And then if we go across the periodic table, when we are talking about cations, they're going to decrease because as you're moving across, you're adding more protons in. And if we're adding more protons in, those positive charges, we're going to end up getting a decrease in the size of those the ions that are formed. For anions, though, just the opposite is true. As we move across, they're actually going to decrease because if we had fluorine here, for example, and it gains 1 electron, then it's going to have 9 positives and 10 negatives. Oxygen, though, will have 8 positives. It's going to gain 2 electrons. So 8 positives, 10 negatives. Those electrons, it's not going to be able to hold it in quite as tight because it's only got 8 positives in there. So as you move across here, it's going to decrease. As you move this way, it will increase. The next trend that we talk about is electron affinity. And this is the energy change is going to happen when a neutral atom gains an electron, and that's called an electron affinity. So it tends to work best with your nonmetals. They tend to have high electron affinities. They want those extra electrons. As we look at this, electron affinity tends to decrease as you move down, and that's because as you move down, you're increasing your distance from the nucleus, so there's not as much that's going to be pulling on those electrons to keep them in. And then as we move across the periodic table, we're going to increase our electron affinity because we're adding more positive charges in. So here's kind of just a brief overview of our periodic trends on the periodic table. You can click on this link on the notes in Google Classroom to be able to pull up that overview for the trends. And then I also have some videos that are linked in as well, so you can pull those up and visit those different videos as well. Okay.